Sometimes I'm fine, and sometimes I go into a coughing fit. So bear with me if that happens. All right. On this worksheet here on 9.3, this is an activity I will do. Usually I do it with you guys, and we'll do it together as a class so we don't leave anybody behind. But I want you guys to follow along with this video, build these, and fill out the worksheet. All right, so before we even get into our baggies, let's look at this because it's been a while now. Gosh, it's been a week since we've looked at any of this, and this stuff can be a little confusing. Not a little, maybe a lot confusing. But remember, I keep telling you, by test time, it makes sense, and it becomes pretty simple as far as knowing how to answer this stuff. So how many electrons can an orbit hold? Well, I'm going to, let me do a box here. Remember that an orbit, I represented an orbit with a box. All right, so how many arrows could go in that box, or how many electrons could fit in that box? If you think back to before, we said that 2, bear with my drawings here also, 2 can fit in a box. All right, so normally we'll have an arrow up and an arrow down. Yeah, you know what I'm doing here, arrow up and an arrow down. So how many orbitals are in the s orbital? Well, we have 4 sublevels, and those 4 sublevels are called S, P, D, and F. We watched a video, and if you remember, they always showed us S and P, and every now and then they would show D, and D had different shapes, but they never showed us F. But if we look at that, how many orbitals, how many boxes? Well, if you look at your notes, because it has been a while, so you may just need to refresh. Let me do a text box here. So how many orbitals can S hold? Well, S can hold 1. It has 1 bottom. Ooh, what just happened to my... All right, guys. Bear with it. It's been a while since I've used Cami. All right, so it can hold 1. All right, so it has 1 box, which means it holds 2 electrons. So let's do the 2 there. All right, how many can the p orbital hold? Well, if you remember back to this, we would go 1, 2, 3. And if you remember back to that video, and it has been a while, they almost look like number 8s or infinity signs, and you would see 1 infinity sign come in, then you would see a 2nd infinity sign come in, and then you would see a 3rd. And the box is representing each one of those infinity signs. So the answer to this first part are how many orbitals are there? There are 3. 3. So if each box holds 2 electrons, there's 2, 4, 6. So 6 electrons. All right, now for D will have 5 boxes. I'm just going to add some boxes here to this one. You guys, it wouldn't be a day if it weren't me struggling with some kind of artistic ability. All right. So there are 5 orbitals. Each box holding 2, so that is 10 electrons. Now F, I'm not going to do it, but you would add, well, I guess I can. I've already added the rest. F, you would add 2 more boxes. Now, they would connect. Mine have little spaces in there. It's just because I don't work Cami well. But if I were to draw this by hand, I would do 1 big box and then kind of break it into 7. So this is going to be 7. And if each box holds 2 electrons, then that would be 14 electrons. Right? Now, normally, like with the elements that we use in discussing chemistry, we normally don't get to F orbital. Now, I'll throw some in there like to practice so you know how to do them. But normally, we won't ever see F orbital all that often. So, let's do this part. Now, I had you guys write down 2n squared equals number of electrons. That's in each energy level. So, if you think back to... Oh gosh, and this was just very simple. When we were doing chapter 4, here I'm going to draw a Bohr model. we did circles like this. I'm going to go ahead and pick this one up. And we saw energy level 1 as this first circle, energy level 2, energy level 3. You guys remember drawing those Bohr diagrams? Now what we saw is that energy level 1 could hold 2 electrons, and then it was full, and you went on to energy level 2. It held 8 electrons, and we went on to energy level 3. All right, so we kept going to 8 because 8 is the magic number, and we'll learn why in this chapter. 8's the magic number for valence electrons. Now, there are other electrons, but there's these 8 valence electrons. So 3, we would have learned, oh, 8, and it's full. Let's go to energy level 4. Oh, 8 and full. Well, really, 3 holds more than 8 electrons. It's just there's those 8 spots in the outer shell. So let's look at that. Let me go back to Cami here. So if I do 2n squared, if I'm in energy level 1, 1 squared is 1, and then 1 times 2 is 2. So energy level 1 is going to hold 2. So if you notice, energy level 1 is full after you do the S sublevel. So then I go to energy level 2, and I will always start with S, right? I'll have S and P now since I'm in energy level 2. So if I do 2 squared, 2 times 2 is 4. 4 times 2 is 8. 8 electrons. Then energy level 2 is full. So then I go to energy level 3. So now that I'm in energy level 3, I will have S, P, and D. So 3 squared, 3 times 3 is 9. 9 times 2 is 18. And then energy level 3 is full, so then I have to jump up to energy level 4. So for instance, in this picture, right here off to the side, I would need to add another circle. So in energy level 4, I will have S, P, D, and now I add F because I'm in energy level 4 and it can hold more electrons. So 4 squared, 4 times 4 is 16. 16 times 2 is 32. And then that's full, and I would jump up to the 5th sublevel, and I would have S, P, D, and F again. So 5 squared, 5 times 5 is 25. 25 times 2 is 50. Now, eventually, because if you add all these numbers up, at this point you have 80. Let's see here, 2 plus 8 is 10. 10 plus 18 is 28. 28 plus 32 is 60, 60 plus 50, that's 110. So right now we're at 110 electrons, and we're getting to like our biggest elements, the furthest on the periodic table. Eventually, I mean, we have some man-made, and they will probably continue to make elements to add up into the periodic table, but we're getting awfully close to, we don't have any more energy levels to go to. All right, so now this kind of just sets us up to now be able to use these pipe cleaners. So I am sorry, I ran out of colors. So some of you are going to have green, purple, red. Some of you are going to have orange, green, and blue. It's just because I ran out of colors. So I tried to like orange and red are similar colors. Blue and purple are similar colors. So I tried to at least get the colors right. All right, so all of you should have 2 green pipe cleaners, and I want you to get those out. All right, what else we have in our bag is we have some beads, and yes, we have some beans. So I'm going to take those out, and I am building this right along with you at my house. All right, so the beans. These beans represent our nucleus, which in our nucleus are protons and neutrons. So I'm just always going to have these beans that I've taped together in the center of everything that I am building, right? Because in that center is my nucleus. All right, now I am then going to grab the smaller of the green, right? There should be 2 greens. One should be small and one should be larger. So I'm going to take the smallest one. And this is going to represent the S sublevel. All right, so it says using pipe cleaner and beads, we will make the 1S sublevel. So first I want you to take, and please follow along. I know we're going slowly, but I want you to follow step by step. Now take a bead. I don't care what color. It doesn't matter. And you're going to put a single bead on this pipe cleaner. This represents 1 electron. So our beads are our electrons. So right now, with this 1 bead on here, I am representing hydrogen. right? Hydrogen right now. But we are going to go ahead and fill that second sublevel. So we're going to take another bead and we're going to put it on our green, our small green pipe cleaner. And then I'm going to circle it around and I'm going to connect it so that it looks like a circle. Right? So I've connected my pipe cleaner to make a small circle with these two electrons, or they're beads, but are two electrons on there. Now I'm going to sit this around my beans. So right now, I have helium. I have a helium atom. It has two electrons. There's only one sublevel, and that is S, and they are spheres. Now, obviously, we don't have, ours is really 2D, but remember, this is really in 3D space. So if I were to draw this, like you guys are going to need to, I've got my green circle, and then I'm going to, I'm just going to put my dots on here. So I've got electron and electron. So now, jumping ahead a little bit, what this is this is what it would look like now if we could see this. But how I would write this, so because every time we do this, we're not going to have to draw these every time. They will do something called an electron configuration, and they will say this is 1s, and since there are two electrons, they will say 1s, and let me do my superscript, say 2. Right? That is telling me I'm in energy level 1. I'm a sphere, right? I'm sublevel S, and that sublevel S has 2 electrons. If it were hydrogen, I would just say 1s. You don't have to write this part, but I'm just showing you. I would write 1s1, right? This would tell me that, hey, I've got a circle, but there's only 1 electron on it. All right, so we've got that. Leave that alone. We're going to leave it just like that. Now you are going to grab your other green pipe cleaner. So remember, up here we said that the first sublevel can only hold 2 electrons. Then we go to the second sublevel. But our second sublevel will have S and P. So I'm going to write that out to the side up here. I maybe should have done that for you guys here a second ago. So let's see if I can. I'm trying to get to where, there we go. This one would be S and P. So what you're going to do is you're going to take your larger pipe cleaner. You're going to put 1 bead, just 1. And if you were to make a circle of it right now and put that down around your other one. Oh, sorry, my pipe cleaner just came undone. And put it around the larger. So right now what I would have is I've got this one, and now I have an even bigger one around it. I'm trying to get it right, but it looks something similar to that. All right, guys. So I'm going to add my electrons. So right now, this is what I have. And of course, my beans are in the middle. I'm not putting those in here. But this is what I have at the moment. Now, this, of course, we're going to fill this one. But right now, this would be lithium. What I'm seeing is I have energy level 1s, and now I have energy level 2s. And there are 3 electrons, which makes that lithium, because lithium's atomic number is 3. And we're assuming these are all neutral. Now, if I were to write this, I don't want an equation, sorry. If I were to write this out, this is what it would look like. 1s, because I do have 1s, right? There's that first one, that first box, 2. And then 2s, and I would make that a 1, because that's what I have right now. And that's showing me, look, I've got 2 electrons, another 1 electron. There's 3 electrons altogether. We're not stopping there, though. So let's go ahead and let's take your energy. Let's take that larger green, and let's add another electron to it, right? Because each orbital, and that's what we have right now is an s orbital sublevel, but there's a single orbital, right, on S. We saw that up here. It had a single box. And they can each hold 2 electrons. And remember, these electrons are both negative and opposites attract. So these negative electrons kind of they repel each other, so they spin in opposite directions because of this. That's why we do the up and down arrow. All right, so I added my second electron, and I'm going to lay it back down around. So I'm going to go ahead and add my second electron. And I'm going to change this here to a 2. Right, 1s2, 2s2. I have 4 electrons now, so I am now beryllium. And then we're going to move on. So we're going to leave that just like this. Now, if I look, I've done my 1s, right? And energy level 1, I can have s. Energy level 2, I have s, and I just finished with s, and now I'm going to jump to p, right? So let's go ahead. I'm going to go ahead and start my drawing for this. Let's do my green. And that is not what I wanted to do. Oh, bear with me. All right. I'm going to do my small circle. I'm going to do my larger circle. I'm going to add my electrons, and now we're going to add to this. It doesn't matter where I put my electrons. I'm just putting them wherever. Okay, now I'm going to move on, and I'm now, beryllium I said? So now we're jumping over to boron. Boron has 5 electrons. So you are going to get, in your bag, you should have pipe cleaner that you have like 3 of. Like you may have 3 reds, you may have 3 oranges. You are going to use those next. Okay? So if you have red, get your 3 reds. If you have oranges, get your 3 oranges out. Now you're going to take one of them. You're going to take one of them, and you are going to add 1 electron to it. Now, if you add 1 electron to it, you are then going to shape it like the number 8 or an infinity sign. Now, mine are never very pretty when I do this, but, you know, just make sure it looks somewhat like it should. So, a letter 8. Sometimes all I'll do is make the 8 they almost look like glasses, and then I twist in the middle, and that gets it to stay. So right now I have the 1 electron. So let me see if I may have to draw this. Yeah, you guys are really going to get to see my artistic ability. Okay. And I am going to do this I'll go ahead and do it in orange. Those of you that have red, just know that this is your red. All right. So it looks, something like that. Not too bad. I thought it would be way worse. It looks something like that, and I've got 1 electron on there right now. So I am boron. If you count all your dots, there are 5 dots or 5 electrons, and you are boron. All right. Now you're going to just undo the end of this, and you're going to add an electron, right? Because this is an orbital. This is one of the p orbitals. There are 3 of them. That's why you have 3 of these pipe cleaners. But this is a single orbital, and it can hold 2 electrons. I'm sorry, don't undo it yet. This is going to be a little bit of a pain, but I want to make sure I tell you correctly so that you don't get confused later on. Go ahead and just put the 1 electron on there, sit it down. Okay, so it is going to look just like we have it drawn right now. Now, go ahead and take one of your other orange or other red, depending on what colors you have, and put an electron on it. And do the exact same thing. You're going to make a loop, kind of like, it almost looks like sunglasses, and then I kind of twist it in the middle so it'll stay together, maybe. And so it looks almost like this infinity sign or this number 8. And I'm going to lay that down on top. So now I have another infinity sign. Starting to look a little crazy with a single electron on it. All right, so 4, 5, 6. Now we have 6 electrons. So if you look at your table, who has 6 electrons, and that's going to be, oh gosh, I just went completely blank. It's going to be your oxygen. Guys, I just went completely blank on my periodic table. Or not oxygen, carbon, my goodness. I was thinking 6 valence electrons. Whew. All right. Bear with me. All right. So now that's done. We've got our third p orbital. So our third p orbital, that third orange or that third red, you're going to take a single bead. You're going to put it on there, and you're going to do the same thing. You're going to make this infinity sign, or whatever you want to call it, number 8. Also kind of looks like glasses. I'm going to put a single bead on there, and I'm going to lay that on top of my s orbitals. So what I have now, this is actually not looking as bad as I thought it was going to. Oh, all right. And I'm going to put my single dot on there. So that's my electron. Now, yeah, you're saying, okay, they can each hold 2 electrons. Yes, they can, but they will not share with each other. They won't share an orbital until they absolutely have to. So if you're looking at nitrogen now, 7 electrons, and you have 7 electrons out here. If you're looking at nitrogen, nitrogen will not share. Their electrons are not going to share an orbital until they absolutely have to. It's not like you have one p orbital and the others are empty. No, once you get to sublevel p, all 3 orbitals are there. And they may be empty, but they're not. Those electrons are not going to share until they absolutely have to. So what we're going to do now is take those p orbitals off, because we're going to modify them a little bit. We're going to take that first one, and we're going to add a bead to it. So I add a bead. And I close it back up. That's what I just did. I added a bead. I closed it back up. So I'm going to add a bead. I think it was to this one right here. Doesn't really matter. So there we go. So now I have another electron. So now I just went from nitrogen to oxygen. Now I'm going to add another bead and become fluorine. I'm going to take one of my other orange p orbitals, and I'm going to undo it, and I'm going to add a bead. Remember these beads representing electrons. If you run out of beads or anything, there is a brown box sitting beside my desk, the desk that I am never at. And inside of that are extra baggies, and there is a baggie in there that says extra stuff. So if you are missing anything at all, you can always go up there and look through that and get what you need. Oh my gosh, I can't get mine undone right now. I don't know what I've done. All right, so once you do that, you're going to add an electron. There, I got it done. Got my electron on there. Let me add an electron. And now I am fluorine. Now I'm going to do that to my last p orbital, the third infinity sign. I'm going to add an electron to it, a bead. I'm going to close it back up, and I'm going to lay that back on top. So now, let me put the dot here. There is an electron there. So if you were to count up right now, you have 2, 4, 6, 6 on your oranges, right? Plus the 4 that are on your green. So you have 10 electrons altogether. You are representing neon at the moment. All right, now to write that out, let me do this here. It's going to be 1s, right? If we're in P, right, we've done 1s. We have our 2s, and it is full. 2. Now, what we first had was 2p, and we did a 1. We did a 2, then we did a 3. It just depends on how many electrons, 4 or 5. Right now, we have 6. Right, so I'm going to end with 6 there. So this is what's called an electron configuration. So this is telling me that I am in energy level 2, and an energy level 2 is full. It's got 2, 4, plus 6. It's got 10 electrons altogether. And we'll see an even easier way to write these things, or especially some of the bigger ones. So we have to, because these can get really long, these electron configurations. We'll see a shortcut around that. Now then, the last step. The last step is you either have blues or purples in your bag, and there are 2 of them, or there should be 2, or maybe the 2 are connected. And that's fine, because that's what I'm going to have you do. If they're not connected, I'm going to have you do that. Connect them so that you have one big long pipe cleaner. So you either have one big long purple pipe cleaner or one big long blue pipe cleaner. Now you are going to add a bead onto that. When I add that bead onto that, this is now, we see energy level 2 is full, 2p is full. So where do I go after 1, 2? Remember, energy level 2 is full after 8 electrons. So now I have to jump up to energy level 3. So up here, 3, I can hold 18. But now that I'm in energy level 3, I'm going to have SP, and I'm going to add a third sublevel, and that's D. Now, we're not going to go that far, but that's what we're doing. All right, so now, as you're doing that, I'm going to go ahead and I'm going to draw what I have so far. It's probably quicker for you guys to draw this than me. I don't know, maybe, look at this. I'm getting really great at this, guys. All right, so there's that. Now I'm going to go ahead and draw, well, let me go ahead and put my electrons on there. I'll never get them on. Okay, there's my electrons. Now I'm going to go ahead and do my P's. Ooh. Trying to draw this the best I can on my computer. See, it wouldn't be this bad if I were at least drawing by hand. All right, let me add my electrons. Okay, now for me, I've got, my baggie has the orange, blue, and green. So I'm going to do blue, but some of you may be using purple right now. And I'm going to have to do a light blue, I guess. I don't know. I think you can find more colors. Do a dark blue. Okay. So I'm going to do, we're in energy level 3, right? We're now in energy level 3. So I have S. S is a sphere, or for our S2D models here, is going to be a large circle. That's why I had to combine 2 pipe cleaners so that it would fit around all this. Okay, so we've got this last one. Right now I put a single electron on it. Oh, I should have just done a blue circle. Oh, I don't have black on here. Well, what in the world? How do I get... Oh, here we go. It would have been nice and neat if I would have just done, you know, the circle option. And this is hard to see. So there's an electron. And then I'm going to eventually put another electron on there, right? Because each orbital, each new thing that we have made with pipe cleaner is a single orbital that can hold 2. So right now with the single electron on there, I am now sodium. I have 11 electrons. Now when I add this second one, I'm going to become magnesium. So I'm going to go ahead and add that second electron. Ooh, there we go. And then you're going to connect the big circle, and you're going to sit it around everything like I have here. So we could continue on, but that would take us a long time and a lot more pipe cleaner. I could then give you guys longer pipe cleaners, and we could then do the 3p orbital, right? Which would then take us, we stopped at magnesium, and take us to aluminum, silicon, phosphorus, and then eventually do D. We'll see where, and then 4S, like then we would jump to energy level 4, but we're just going to do, you know, this right here, be simplistic, so that you guys can really get the sense of, hey, each of these orbitals are holding 2 electrons. The S, my circles, there was just 1, and then I moved on to something new. Whereas my P, there were 3 of them. There were 3 oranges. I had to make 3 infinity signs, each holding 2 electrons. So I was hoping that this would visually get you guys seeing exactly what we're doing, since we can't see this stuff in real life. As far as my electron configuration here, which we'll talk more about in the upcoming notes, it would be 1s, 2, 2s, and you can see where I'm just literally copying down what I did just a second ago, 2p, 6, but now I've added to this, right? And now I'm at 3s, 2. Once again, if I would have had you make larger infinity signs, we would have then been like, oh, 3p. Maybe if I would have given you 1, we could have then said, oh, 3p1, right? We don't always have to be full. We happen to fill these up, but I could have given you 1 more to make a p sublevel, and we could have said 3p1 and then quit there, but I didn't. So we'll get rid of that. All right, so this is just kind of a guide to help you out. It was more there because kids were struggling so much with this. I wanted to visually be able to show you and have you guys build this. Okay, now as far as your classwork, 9.3 worksheet, use this to help you. Use your notes to help you. When it says describe the shape, I mean, you guys saw the shapes. It does not matter if it's 3p or 4p. A p orbital is going to be the same shape. I don't care what energy level it's in. It's going to be the same shape. What is similar about the following? Well, tell me, is it the shape? Is it the energy level? Is it how many electrons are in there? I mean, just tell me whatever you think. On 9, and this is for participation, but you need to turn this in. And like I said, I've been telling everybody all week, if you could either do this online and submit it that way, because you all have a copy on Google Classroom, or if you want to do the hard copy, that's fine with me. But if you could please try to take a picture on your phone and submit it that way, attach that image to the assignment and oh gosh, submit it, then I could grade it that way. It's going to be a complete mess if I have to try to grade every class when I get back next Monday. Okay, so indicate the number of each of the following orbitals, so n equals 2. So remember, if you're having trouble with this, be like, okay, energy level 2. Maybe go back to this and be like, in energy level 2, the second electrons in the second, I should say energy level instead of sublevel here. How many sublevels are there? There's S and P. Right? Don't forget that this one is going to have S, P, D, and I'm in energy level 4, so I'm going to add F to it. All right? So kind of use this to help you. Or how many orbitals, though? This is orbitals, so think about this. How many orbitals are there? Well, S has 1, and P has how many orbitals? It's more than 1, I can tell you that much. I'm not going to give you the answer. And this is, once again, participation, so try your best. How many sublevels are in N equals 4? Well, I just kind of told you that one. How many orbitals? Remember, that's how many boxes. An orbit is a box. Okay, don't forget that. 9.28 can be tricky because you really have to look at this. They want to know how many electrons. Well, S. As soon as I see S sublevel. As soon as I see P, I want to be like, oh, there's 3 boxes, which means 6 electrons. That is not what it's asking. It wants a 4p orbital. That is all I'm going to say on that one. Let's see if you guys figure it out. All right, so just try your best on this. I will do a video going over these answers as soon as I get everybody's worksheet. But if I have one out, I won't put the video out yet, or I may get a hold of that person and be like, hey, I need your work, or it's going to be a 0 if I do the video. All right. So I hope you guys are doing good. I miss you guys. I want to get back to school, so I will see you guys soon. Have a great rest of your day. Bye.